Let k be the largest integer such that the equation x minus 1 whole square plus 2kx plus 11 equal to 0 has no real roots. If y is a positive real number, then the least possible value of k by 4y plus 9y is right. Doable question. Expand this. This becomes x square minus 2x plus 1 plus 2kx plus 11 equal to 0, which is x square plus 2k minus 2, 2 times k minus 1 times x plus 12 equal to 0. This has no real roots, so discriminant is less than 0. B square minus 4ac is negative, or b square is less than 4ac. 4 times k minus 1 whole square is less than 4 times 12. K minus 1 whole square is less than 12. K be the largest integer such that this works. So k minus 1, I'm thinking about positive integers because that works better. K minus 1 could be 3. K minus 1 should not be 4. 4 square is 16, 3 square is 9. K minus 1 is 3 or k is 4. I don't have to worry about k being minus 2, minus 3 because we're looking for the largest integer, k equal to 4. Y is a positive real number, the least possible value of k by 4y plus 9y. So 4 by 4y plus 9y. 1 by y plus 9y. This is greater than or equal to a plus b is greater than or equal to 2 times a plus b by 2 is greater than or equal to square root of ab. Arithmetic mean is greater than or equal to geometric mean. Positive real number, we can plug in arithmetic mean, geometric mean. We are finding arithmetic mean, geometric mean of 1 by y and 9y. A plus b by 2 is greater than or equal to square root of ab. A plus b is greater than or equal to 2 times square root of ab. 2 times 1 by y into 9y. Square root of 9 is 3. This is greater than or equal to 6. The least possible value is 6. We are using the idea that a plus b by 2 is greater than or equal to square root of ab. Arithmetic mean of two positive real numbers is always greater than or equal to geometric mean of two positive real numbers. As long as both are positive and real. So AM is greater than or equal to GM. We're plugging that idea in and getting 6.